south, how far downstream does he end up? So velocity he swims at is
1.5 meters per second.
1.5 meters per second.
Yeah. And the water flows at 0.67.
Okay, and that's towards the east?
Yep.
So that's this way. Okay, so far so good. What we said the velocity was 0.67. Okay, so first thing you do in this question, it's different than all the other questions because usually you try and find that guy. But the first thing you want to do is find the time. So what's the time it takes to get across the river? Well, the time it takes is if you do it, you calculate it as if there's no current. Okay, because he's not swimming into it, and he is going to eventually somewhat swim with it. So you take 98 and divide by 1.5. I don't have the answers. 65.3 repeat.
Yeah.
All right. So 65.3 seconds is the time it's going to take him to get across the river. Now, if we know it's going to take that amount of time, that's the time down here as well. So now what do? It actually asks us, how far downriver are you going to end up? Well, you have the speed at which the current is moving at, and you have the time it's going to take to get from one side to the other, so you multiply the two. And that worked out to 43.773 meters. Okay?
Okay, so what was that for?
That's how far downstream you can end up.
Okay, because I ended
That's
up with that somehow, but I didn't get the time.
Okay? So that's all there is basically for that part of the question. You're just working on it as if he's swimming straight across. He's going to move with the current. So he's going to end up somewhere down here, right? Instead of straight across. So then the question says, well, what angle would he have to swim at to end up straight across? Well, he wants to end up right here, and the current is moving that way, so he needs to swim like that to get there, right? And what is he swimming at? What's his speed? 1.5 meters per second. Speed of the current is 0.67, right? Okay, so now say to yourself, well, actually we don't even have to do that. Let's just find out what it is. So I will accept, if you actually do put directions on this question, I'll accept that. But if it asks you what angle is relative to the shore and you give me this angle and not that angle, then it's not going to be right unless you have the actual directions in there. Okay? So this angle right here was 26.530 degrees. And then this angle relative to the shore is the one it's looking for, is the complement of it. So 63.470 degrees.
How did you find
Sine of 0.67 divided by 1.5. Like that.
And that gets you 63.47?
No, that gets me 26.53. And then you need the complement to get the angle that's relative to the shore that you're swimming at.
sine 67 divided by, or 0.67 divided by
1.5. You're going to use second sine because you're looking for the angle. All right? Then it says, how long is it going to take to get to that spot? Well, are you swimming faster, slower, or the same speed in this situation? You're swimming at the same speed, but it's going to appear that you're going faster, slower, or the same. You're swimming into the current now, so slower. So now when I calculate it, 1.5 squared subtract 0.67 squared equals that and then the square root of it.
And so that straight up and down leg, what does that represent?
That's straight across from where he started.
Yes, but that speed, that's his.
That's how fast he's actually going. If you were standing here watching him, that's how fast he's moving across.
Okay.
All right? And remember, if somebody's swimming, they're not swimming way out this way and coming all the way back. They're just doing little guys, right? So if you were to look at it and you were to take somewhat of a straight line, you would see that he's only swimming at that speed instead of 1.5. All right? Because again, it's like if you're running into the wind. You're not running the same speed if you're running into the wind. You can't swim the same speed if you're swimming into a current. All right? It's going to slow you down. So that's what the speed is. So now I take 98 and divide by that to get the time it's going to take to get across. And I got it at 73.023 seconds. Yeah? Okay? Questions about it, other than that one? Rex?
I did all the difference without seeing answers.
Okay.
So is that good or not?
Well, it depends how you draw it. You gotta draw it. How did you draw it?
I have it all upside down and I just actually both like this.
Okay, yeah, okay, that's fair. The only thing is the question said south, so you need to.
Yeah. It's,
Oh, I drew it
got
north
my
as well.
directions.
Yeah, all right, I drew it north as well, but there is a question. So, but yeah, if you gave me, in this case, if you gave me south 26.53 degrees west, I'd mark that right. Okay? If you gave me south 26.53 degrees west, I'd mark that right, because that is the correct answer.
Which you have to put in your direction.
But you have to have the direction, yes. Because the question specifically says relative to the shore.
When I put the sign, like that
Second
function sign,
Yeah.
and then put that into my calculator, give me like 28.0.
26.530. 1.5. No, don't close the bracket on that.
No?
No, it has to be 0.67 divided by 1.5, has to both be in the brackets.
Okay, that makes sense. Yeah.
Okay? All right, anything else on this question? You're gonna see it again on your test. Only 2 steps to it, really.
Yeah, what was the formula, like how did you get the velocity when he's like swimming into the,
Use the Pythagorean theorem. This squared subtract that squared equals this squared, because that's your hypotenuse. Okay. Anything else? Okay, let's go to the next one. All right, next one. This was a tougher question than what you had in your book, but of course, since you got an assignment, since you get to use your books, I can't make it easy for you. All right, so I changed it up a bit. And instead of flying with the wind, this is the first one that you actually flew into the wind to do the question. So it says that I want to end up 1,400 kilometers away, 46 degrees west of north. So I need to end up right here. That's my end game. This guy right here is 46 degrees, right? So this is basically my velocity of my ground. That's what that has to be. Okay, that's not what the plane's flying. That's where the velocity of the ground is. Now, the wind is blowing to the west. So if, this is the question I was asking you yesterday, Austin. If I flew right at it, where would I end up? Would I end up where I want to be? No. Because why?
You fly further west because the wind's going to push you.
I wouldn't fly, would I fly further west? No, I'd fly further east.
Sorry, it's coming from the west, not
Yeah,
to the west.
right. So you gotta watch that. So that means then I would end up somewhere over here, right? If I flew straight at it, I'd end up over here somewhere. Correct? So how does the pilot compensate for that? He flies
Further west.
further west. So he's gonna fly somewhere on this line right here.
so they can push some of the stones up.
That's right. So this is the plane speed, which was I think 320 kilometers an hour.
Yeah.
Correct?
Yep.
but he's flying into a wind that's going what? 66 kilometers an hour? Okay, there's the hard part of the whole question right there. We know how to do triangles. We know how to do right angle trig. We know how to use law of sines. We know how to use law of cosines. What we don't know necessarily is how to draw these properly to use that information. Okay? And if you get to that point, you should be able to complete this question, but getting there is the hard part. So, I got to know an angle in this triangle.
46.
That 46 would be right here.
Or 44.
46.
Correct?
Oh,
Yeah. And
Right.
would be 90, would be
And then you have to add the 90 to it because this is a right angle right here. Because that's straight west. Okay? So now my triangle, I have 136 degrees. Okay? Now, at this point then, let's find the rest of the information in the triangle. Let's find all the angles first, and then let's find the other velocity, which is the ground's velocity. So to do that, I know that I can find this. I know this is 136 right here, right? And I know the side across from it. So let's find out what alpha is. Sine alpha. What's the length of the side across from alpha?
66.
66. My other angle is 136, and I know that, right? And what's the length of the side across from it? 320. So let's calculate that angle right now. I want to find out what alpha is.
8.237.
8.237? Yeah, that's what I have as well. Yeah.
That's
Okay, that's this angle right here, from there to there. So the question says, at what heading, meaning direction, right? So what heading do I gotta go? So you gotta give me an actual direction. Okay, so clearly, I see that it's 46 if I go north and then somewhat west, it's 46 west, right? So I'm going to go north, and I'm going to add that on to the 8.237. 54.237 degrees west is the flight path, is the heading, is the direction that the plane needs to fly in order to end up at 46 degrees north, west of north. Okay? That was the first part of this question. What was the direction? That was the direction right there. The complement would have been west 763, I think, something like that. And the complement's fine. If you give me the complement, I'm all right. Go ahead.
The 90, like the red triangle, because what I did when I redid it or whatever, I like the red triangle, is that a right angle triangle? So like.
There's no right angle triangles in this question at all.
That's what
Yeah,
I did.
that's
too.
good.
Then I put 90 like up in that corner and like
Yeah,
push
yeah.
44, and
Yeah.
then I got 136 just because I knew it had to be 180, but you can't always do that.
No.
That's so lucky.
Yeah. Well, maybe not.
That's the way I did it. too.
Yeah, if it works,
I'm saying you gotta-
it might work.
Yeah, instead of
Well, I got
using
Okay, so let's talk about the question now again. All right, that's the heading that he's got to fly. So is he going to make time on the direction he's flying? Is he going to lose time on the direction he's flying? Or is he going to go the same amount of time on the direction he's flying? How come? Because he's flying into the wind.
ground speed
So-
slower.
Let's look at this question as if there was no wind. That means that he would fly straight there at 320 kilometers an hour, right? So to find out the amount of time that would take, I take 1,400 kilometers and I divide by 320 kilometers an hour. and I get 4.375 hours. So that's if there was zero wind and I was able to fly straight at it. It would take me 4.375 hours. But I'm not going into the wind. Or sorry, I'm not flying without wind. I gotta fly into the wind. So that means I need to find out what that guy is right there.
Can you do the?
Nope. Nope, because there's no right angle. Right. So, what can I use for this? Well, I know this angle right here, right? 8 something? 0.237. I know that angle right there is
136.
136. What does that make this angle then?
35.7.
I don't think you have, to find the ground speed, do you?
You do in order to answer the whole question, yes. The last part, does the last part of the question not say how much time did the wind save or lose?
Yeah.
So then I gotta find out how fast he travels.
Oh, so you have to find the ground
Yes.
speed and then like subtract it or something?
Yes, that's exactly it. So the velocity of the ground then, I'm gonna find it by going VG over the sine of
35.
35.763. That's equal to
320.
320 over sine 136. So the velocity of the ground then, calculate that please. I got 269.224 kilometers an hour. That's going into the wind. So that's the speed he's going to travel going into the wind. The 320 would be without wind. Yeah. The 320 is without wind.
What did you get?
269.224.
I did it.
Using this.
Oh, I didn't use the, what's it called, the decimals, so I was looking.
Okay. All right. So now I need to find out
Then you gotta subtract your
the time it's going to take now. So take 1400 and divide it by 269.224.
And then that time subtract.
5.2.
I get 5.200 hours. So then, is it taking him longer to fly into the wind?
Yeah.
Yeah, so he's going to lose some time. So I take 5.200 and subtract that value, and he loses 0.825 hours. Okay. So again, the whole key to this question is basically the logic here. Knowing how to set that diagram up to help us solve the rest of the graph, right? And that's, hey, do I fly into the wind to end up where I need to, or am I flying with the wind to end up where I need to? Okay? Anything else? Anybody want to add anything to this? Questions?
I just did it the same way as,
The second time I did it.
What I had done was, instead of finding my ground velocity, I never actually did find it. I found the distance of my plane's travel, and then I did that distance divided by that speed, because it would be like larger than if I just went straight there, like how much time would be lost. So I got 5.2 hours.
You found the distance for this guy?
Yeah.
How did you do that?
I did 1400 and 343, like 1400 squared and 343 squared, which is my top distance. Because like I just found my distances, because you take your 1400 meters and you divide by 320, and it gives you your time it would take if there's no wind. But I found my longer distance, so it would give me a higher.
My question to you is, how did you find your longer distance?
I found my length of the 66 kilometers per hour, and then I used
How
my,
did you find that length?
I did C over the sine of 8.237 over 1400 kilometers, and then the sine of 35.763.
Okay. Now, I have no problem with that.
Does that work just once, or will that work?
No, I think it should work all the time. The biggest thing is you can't be flip-flopping units, and you weren't.
Oh,
You did this whole thing using distance. It works that way.
Yeah, you can't do like kilometers per hour and then kilometers. Yeah.
Right. Okay, so that works. I would normally only use the velocities, but if that works for you, then I'm okay, and you understand it, and your triangle came out the same way, you shouldn't have, like, we know from the river question, the velocities and the distances and the times, they all correlate to the actual triangle's lengths and angles. So yes, that is a way you could do it. If you use distances, you could have done it that way. So then you would have found this to be a longer distance and then
Yeah.
divided by 320.
And then divided the without wind by 320.
Yeah. Yeah, that works. Okay, I would have never done it that way, but that's great. Okay, there's nothing wrong with that whatsoever. All right. Okay. There's nothing else in that one. 3.
That was easy.
3 was pretty good.
3 is just a lot of work.
Yeah.
It was a lot.
But it's-
I was smart too.
Okay, so all you have to do is find the 4 vectors, right?
I got
You happen to have the 4 vectors. Like on your
Sorry.
You have the 4 vectors on your thing.
Do you want to know like the X's and Y's? Is that what you're asking? Okay, so the first vector's components. Here, I'll write out my components, and you can check your answer with my components.
That would be helpful. Yeah.
Okay, so the first vector, I got 240.726 east and 319.454 south. The second vector,
440.
yeah,
440.
oh, 440.
No, I had it on the other side, Brock, and I got lost.
I have mine mixed up too.
That's west,
What's west? How's 440?
and that'll be 206 south. So I mixed these up, so let me, okay, I need you not to be chatting back there, okay?
Is it?
So I got 440, and then my other one was, this was 275.558 south. Okay, and then now, yeah, I'm trying to follow it in order because mine's a bit all over the place as well. So then I had 294.895 west
Yeah, that's right.
and 206.488, and that's north. And then my final vector was 280.074, and that was east,
Same.
and 107.510, and that was north. So yeah, exactly what you just said, Rowan, is there was 2 east, 2 west, 2 north, 2 south. Probably. I mean, I can switch it, but.
Yeah, don't say that. I'll stitch it.
Yeah, I mean, like,
it won't change either way.
It could be 3 norths and a south.
Brooke, go ahead.
Can you show me how you got those? Because I got completely different, or at least like the first 2, because I got completely different numbers.
All I'm using is sine and cos. So
Okay, so I probably just used the wrong one then.
on this one, okay, so this was 37 degrees right here. All right, and this is 400. So this is sine 37 times 400 right there.
Yeah.
That gives me that.
I didn't take into account the degrees they
Oh, you
gave us. Okay.
And then the cos of 37 times 400 is that one.
Yeah, okay.
Okay, what about
Hear
the
this
440? I have 440 as south and 275 as west.
I have that too.
Yeah,
It doesn't
I have
matter.
that too.
It does matter.
But it does and it's wrong. I redid it. It's because
I'm gonna draw it like this, bro.
you go west.
Yeah, that's how I have
That's
mine
how
drawn
it
too.
was.
And then did you have this here and this here, right?
No, mine's backwards. If I would have like.
You went down and over?
Yeah,
That's
So
why.
it's
Same.
like down.
Okay, so here's the only issue, Brock. All right?
I'm not sure.
That's 37. If you do it your way, That's 53.
Oh, I can't believe that state.
Oh, sorry, 32. My bad, sorry. That's 32. That's 32 degrees, and that would make that 58 degrees. So that's how come yours are opposite of mine. If you drew it down like this and over, you put 32 right here.
Yeah.
That's wrong. Yeah, because it's west,
Oh, yeah.
32 degrees south.
West first, that's what I did too.
Okay, so does that, you understand that, Brock?
Yeah.
So your work,
Yeah.
right on,
Everything else was.
the only thing was
It's
the
because
direction.
Brock,
here.
I did that too, it's because everything's north first or south first, and so we just kept doing that, but this one was west first, then south, and I just, yeah,
That's how
I fell for it.
Okay, so far, so anyways, the question worked out. The final answer was 353.876 kilometers, and it was south 37.429 degrees west. Okay?
Well, I was so close. I was one number off with the kilometers.
I'm getting my numbers wrong. I was really close
Okay,
to my actual.
So,
Yeah.
again, you're, like all these questions you're gonna see on the test again, right? So,
Okay.
this one, again, like you said, there's a fair bit of work to it,
Yeah.
but all you're doing is sine and cos
Just
of
time-
and multiplying, as long as you draw your vector directions right. 'Cause that's the only, that's the error. Go ahead, Rex.
What are we doing after vectors?
Pardon me?
What are we doing after we finish vectors?
We go into, I think it's momentum, which is, no, sorry, it's Newton's laws. So there's still some vector work there too.
Coincidence?
Just your laws, eh?
Yeah.
Good man.
Okay, pilot wishes to make a flight 600 kilometers south 20 degrees east in 45 minutes. On checking with the meteorological office, she finds that there will be a wind of 80 kilometers an hour from the south, so that means going to the north, right? What heading and airspeed must she use for the flight? Okay, so I got velocity of the ground is velocity of the plane plus the velocity of the wind, right? And what I'm looking for right now is the velocity of the plane. So that means I have to subtract the ground or the wind from the ground, correct?
Yeah.
Okay, so she wants to go 600 south 20 degrees east. So I'm gonna go like this. That guy right there is 20 degrees. Okay, we gotta not busy here. That'll catch on the microphone. All right. Now, what's the negative of the north wind? So I'm going to go down this way, right? So I'm just going to mark this in here and make that 20 degrees right there, okay? So what I'm trying to find is that right there, which is the velocity of my plane.
And 30s in that.
Why do you have 20 degrees there?
So that's your
Oh,
all
never
right.
mind.
This one?
Then you just 180 lines back to each other.
Wait,
Good.
wasn't the wind?
So now I have 160 degrees right here.
This one? Southeast?
Wants to make, Austin, I need you to stop talking, please. 600 kilometers in 45 minutes. So how fast does he have to go?
800 kilometers an hour.
800. You're going to take 600 kilometers and you divide it by 0.75. Right? So the velocity of the ground is right here. He has to fly at 800 kilometers an hour. So the combination of the plane speed and the wind speed has to be 800 kilometers an hour in order to do this flight. What is the wind? 80 kilometers an hour. Now you use your law of cosines. Yeah, Brock.
Why do you divide it by 0.75?
45 out of 60. Because it's 45 minutes and I need to find out how much it is in hours.
Distance over time is velocity.
But he's asking about the time part.
Yeah.
Why 0.75?
Oh,
It's 45 out of 60. Okay? So I got the velocity of the plane. In order for that to happen, the plane must fly at 875.603 kilometers an hour. All right, now, and the direction, that guy right there, this guy I calculated to 1.791 degrees. So it's south 18.209 degrees to the east. Okay, now again, my question to you is this. He wants to fly from there to there, right? And again, if he wants to fly there, he's got to fly into the wind to end up there. So is he going to have to fly faster or slower than what the straight arrow one was? He's got to fly faster because he's flying into the wind. So then it's going to take that into account for him to make it at 800 kilometers an hour. Okay, so that's why this value right here has to be greater as well. Where's the largest angle in that triangle?
Opposite the
160.
longest side.
Opposite the longest side. So you know that if you don't have those simple triangle rules, right? Then you know you have an error.
So you just like solve that like 875. You just use the sine laws.
Coastline. Love cosines.
How do you even do that?
You could use sine.
Because we went 160.
If you found the other, no, you can't. You have to find that side first in order to get to the sides, because you only know this one angle.
Oh, right.
And I don't know the inside across.
They cut that off.
Yeah.
So you like
So you use
this square.
Oh.
Oh, this is the wicked long formula.
Yeah, it's the longest
Oh, this is the one that put long to me like why did you?
Yeah,
Plus negative 2 times.
I don't even remember now because I can't.
I always forget to know.
So
Just take a good look.
So from where you are,
Okay, Austin, come on now.
I asked them.
I know, you guys you're on the camera. So, yeah, go ahead.
You use the sine law to find the angle though, right? Okay, I'm just gonna.
That's right.
Oh.
Yeah. Here's what I did to find that little guy up there. I'll move it down here. Sine alpha over 80 equals sine 160 over 875.603. That's what I did to get that little angle, 1.791.
Do we have formulas like during our test, or do we have to remember
I don't know if it's on here. You get that whole formula, like remember I gave two-sided formula sheet? Have I given that to you yet?
yeah,
I did in the first test, right, with the kinematic stuff?
those?
It might be on
Oh,
I forgot all about
what is that?
there. Okay, all right.
seems
that.
I got one last question to do. Any other questions about this? Again, the question that you had in your book was the wind was blowing,
With it.
yeah, with it that time. Let's see. Okay. One last one, and then you guys should get out of it. I'll just draw this last one for you. Airplane wants to maintain a heading due west at an airspeed of 900 kilometers an hour. It's flying in a hurricane with winds of 300 kilometers an hour from the northeast. Okay, so he's flying west. Velocity of the plane, 900 kilometers an hour. From the northeast means southwest. Southwest, that makes that angle, the whole angle what?
135.
135. And that's 300 kilometers an hour. So we know this is 135.
How
Okay.
did you figure out 135?
I didn't know.
Because this line right here is because it's southwest, it's 45 degrees. So 45 there and 45 here, and then add 90.
You could just assume that it's 45.
Because it's southwest, that means it's directly between the two directions. So that means it's 45. Okay? So We got this angle right here was west 10.799 degrees south. And the velocity that it was traveling at was 1132.183 kilometers per hour. Again, that's law of cosines. 300 squared plus 900 squared minus 2 times 300 times 900 times the cos of 135. And then you just divided that value by 500, or divide into 500. And you would have got 0.442 hours or 26.52 minutes. Okay? All right. So, again, I explained it to you this morning and applied. I'm going to tell you again. The whole point of this, number one, is hopefully you get better marks, because you get to use your books for it. But if we're not copying the stuff down off the board with the examples, then you don't have them to look at when you do these questions. Right? So then now you're basically writing a test now. All right? The second thing is, it's to show you how much you need to improve or if you've got it. Okay? So it's 5 questions. Your test is, and most of you didn't finish in the time,
Yeah.
your test is going to be 8 questions.
Oh, that's great.
So you got to make sure that you're, or 7 questions, whatever it is. You got to make sure that you're prepping for it. Okay?
more of these
So,
sheets?
Yeah.
like more, like with questions like this,
Yeah.
like more questions than the textbook.
Yeah.
I'll look back there. I think I have some that they're not quite as good as this, but there'll be some questions. Go ahead, Amber.
Can we go back to question 4 when you did that small angle, like we did,
Yeah.
You did sine 80.
Sine alpha over 80.
Oh,
Sine
okay.
160 over that.
That did it. Okay. That's it.
Okay. Yeah. All right, so what I would suggest is in and around the questions that I assigned you, probably find a couple questions in there, and then I'll look and see if I have some sheets that I can, or a sheet or two I can photocopy. I have no problems pushing this unit or this test to the next week. All right, but I need more out of us in this classroom. Okay, we shouldn't be at this point where I look at this and I can't get 2 out of 5 questions done when you logistically should have a test tomorrow. All right, so let's just get to work. Let's do these questions. When I put questions on the board, make sure they're in your books. All right, otherwise you're not getting better marks. Okay, so it's twofold. Any other questions about this today? Okay, so you've got your work to do right now. I want you to work on that. And I will see if I can find more questions for you.